In this video, we're going to determine if we have parallel or perpendicular lines based off of our equations. Perpendicular lines intersect at a 90-degree angle. Parallel lines are the opposite of perpendicular lines. They will never intersect and will always be the same distance apart. When we have two or more equations, we can determine if the lines are parallel or perpendicular by their slopes and their y-intercepts. This first question says to determine if the lines are parallel or perpendicular. Well, as I just said, you can determine if lines are parallel or perpendicular by looking at their slopes and their y-intercepts. Because we're comparing slopes and y-intercepts, it helps to get them in the same format, which is y equals mx plus b. That's slope-intercept format because we're given the slope and the y-intercept. This first equation is y equals 2/3 x plus 4. It's already in slope-intercept format. We can easily see that our slope is 2/3, and we can see that our b, or our y-intercept, is 4. Let's go ahead and graph that at the right. We can start with our y-intercept being 4. Our slope is up 2 and over 3. We could write this as -2 over -3 to help us graph in the other direction. Now we can connect our dots and we have our first line. This second one is not in y equals mx plus b format. We can get it easily in y equals mx plus b format by adding 1 to both sides. Now we have y equals 2/3 x plus 1. Our m is 2/3, and our b, or our y-intercept, is 1. Let's go ahead and graph this. Since our y-intercept is 1, that's our starting point on the y-axis. We're going to rise over run, meaning we're going up 2 and over 3. We could also do -2 over -3 and go in the other direction. As you can see, our two lines are parallel. So what do you notice about our two equations? If you noticed that our slopes are the same, but our y-intercepts are different, you're correct. If you have the same slope and different y-intercepts, the two lines are going to be parallel. Let's go through another example. This one says to determine if the lines are parallel or perpendicular as well. Again, let's put it in y equals mx plus b format if we can. This first one is, our m, or our slope, is 1/3, and our b, or our y-intercept, is 2. So if we graph this, our starting point is 2 on the y-axis, and we're going to go up 1 and over 3. We could go in the other direction by going down 1 and backwards 3. Connect your dots and you have your line. This second one is not in the right format, but we can quickly get it there by adding 4 to both sides. So we have y equals -3x plus 4. Our m, or our slope, is -3. Remember, we need to write that as a fraction, so we can put it over 1. And our y-intercept is 4. So starting at 4, we're going to go down 3 and positive 1. Down 3 and positive 1. What do you notice about our two lines? They're perpendicular. Now, what do you notice about our slopes? Our slopes are negative inverses of each other, meaning one is positive, one is negative, and they're the reciprocal of each other. When trying to determine if lines are parallel or perpendicular, you can always graph them. However, you can also look at their slopes and their y-intercepts. If the slopes are the same and the y-intercepts are different, then you know the lines are parallel. But if the slopes are negative inverses of each other, then the lines are perpendicular.